Hello everyone, good morning. This is class of 11th mathematics. In this whole video we will focus on sets, which is chapter 1. Now guys, our agenda is clear for this class. First we will discuss on sets and their representation. Then we will discuss types of sets, where we will discuss the empty set, finite sets, infinite sets and equal sets. Then we will explore subsets on the basis of real numbers as well as intervals. Then we will discuss universal set. Then we will discuss Venn diagrams. Then we will explore operations on sets, where we will discuss union of sets, intersection of sets, difference of sets. Then we will discuss complement of sets and their properties. This is our whole agenda, which will be very interesting topic. So this is the interactive class. So let's start. Look at these figures. What do you think about sets? Here, look at this figure. Here you will got a interesting pattern, a well-defined geometry here of circular things. This is a circular object and pattern of circular object is well defined. Same circular. Then after this you will get a regular shape. Then you can say that after patterning, after a set of geometry, set of equal sense, then you will get a new object which will be well defined, which will be appropriate. So we can say that requires of knowledge on the sets, which is the foundation of every mathematics, such that geometry, sequence, probability. So all these want to have a require of knowledge. So the concept of set serves as a fundamental part of the present day mathematics. Today, this concept is being used in almost every branch of the mathematics. Sets are used to define the concept of relation and function as well, because after watching this, looking this figure, you will get that this shape is related from a well-defined geometry, well-defined pattern, well-defined sequence. So this is very essential. So first point, what is about sets? What do you understand sets? Then we can say that a set is a well-defined collection of objects. A set is well-defined. A set is a well-defined collection of objects. Here we were saying that a well-defined pattern, a well-defined pattern of same shape, that means circular. So a set is a well-defined collection of object. Is a well-defined collection of object. Now, which type of objects? Here the same pattern. So we can say that object, elements and number of set are synonyms. Clear? Now, here we have written natural number. That means it is the collection of well-defined numbers, accounting numbers, 1, 2, 3, 4 and so on. A well-defined pattern. There are differences one between this 1, 2, 2, 3, 3, 4, and if you say it is the set of 0, no, you cannot say, because you have defined it. This is a counting number, so this is a natural number set. Now, if you look at another set which is very important, if you say integer, what do you understand? A set 0 plus minus 1 plus minus 2 plus minus 3. The set of all integers are well defined because it has 0, 1, 2, 3, minus 1, minus 2, minus 3 and so on. That means if you say P by Q is the element of this set, no, because P by Q is related from rational number. So every set has a different elements which has some property. Here we cannot say 1 by 2 is the element of integers. Why we cannot say? On the basis of why, we can say that we can define this set in two ways. So next point is representation of sets. Representation of sets. Can you represent the sets? You can represent the sets in two ways. One is roster. And other is a rule. One is a tabular. Other is a set builder. How can I recognize these sets? That is very simple. If you want to say set of all prime numbers less than 11, here our statement is set of all numbers which is prime less than 11. Then we can represent this statement in two ways. One is roster, other is a rule. So in the roster column, we can say that 2, 3, 5 and 7 is the only element which define this statement. Now we can write the same things in other ways. On the basis of rule, we can say that x such that x is a prime number is a prime number is a prime number and x is less than 11. So the same things we can represent. One, there are lot of elements and other is on the basis of rule. This is the whole things to understand. Clear? Now, if you want to represent any set, then you should use a capital letters. You should use capital letters to represent any set. And these elements should be small letter, should be in small letter, such that A equal to A, E, I, O, U. This is the only representation symbols what we use to represent the set. Clear? This is the way to represent the sets. Now come at the next point on the basis of type of sets. So first point is the empty set. What is empty set? What do you understand about this? That is the most important point. What do you think? Look at these figures. If you do not put any objects, then you can say your room is empty. Suppose this is a almirah here and you do not put any articles, then you can say your almirah is empty. So in the same way, we can say that a set which does not contain any element, a set which does not contain any element, we can say that is empty set or the null set or the void set. So if anybody asks what is void set, then you can say the same definition for empty set. A set which does not contain any element is defined as void set, is defined as null set, is defined as empty set. So first point, you should a clear understanding about the room. That means the room where are no articles. A room without any articles. A almirah without any clothes, without any things. That is the motto to understand empty set. Can you provide any example for this? This is the real scenario, but what is the representation of the empty set in mathematics? First, we can use the symbol for empty set, which is phi. Phi means a set which has no element. The same things. In examination, You should have a clear understanding about these symbols, about this notation, because they ask the same things in a different way. But if you have understanding about the phi and symbol, then you will be able to explore and you will be able to clarify the empty set. Now, any example? If you write, let A is the set where X is the element such that X greater than 1 and less than 2 is an where X is a element of natural number. So this is the empty set, because you cannot take any number which is greater than 1 and less than 2, because 1 is natural number, 2 is natural number. Between these 2 point 1 and 2 there are many irrational and rational numbers available. So but you are using natural numbers, so we cannot get any natural number which start from 1 and ends with 2. So we can say this is a empty set. That is the point. Now come at the new point. What is finite sets and infinite sets? That is the point. Finite, that means you are defining that definite number of collection. That means you will be able to count it. You will be able to limitize this. So what can you say? A set which is empty or consists of a definite number of element is called finite. That means you will be able to calculate. A set which is consists of definite number, which is consist of definite number of elements. Definite number of elements. Clear? Is called finite, otherwise infinite. Now how can I? That means infinite set you can count. You can count and limitize. Here as well as you can count, but you cannot limitize. That is the point. You can count the both sets, but you cannot limitize. Do you know empty set is defined as a finite set as well, because you can count, you can limitize the number. That means there is no availability for any numbers, any elements. So you can say this is the finite set. Here there are no elements, but you can count it. You can limitize. That means you know there are no elements. So this is the finite. we are taking this example because it is essential to clear the concept what is finite and what is infinite. Clear? Now we should take an example which will be very helpful to understand. Now here the set such that 1, 2, 3, 4 and the set the same things 1, 2, 3, 4, 5 and so on. Here we can enumerate 1, 2, 3, 4. This is the collection of 4 sets. So number of sets is represented by this bar. Clear? This vertical line. If you want to calculate a number of any sets, then you can represent number of sets as this way, and this is 4. Now what can you represent? Can you calculate the how many numbers are involved to represent infinite set? You cannot count. That is infinite. That is infinite because you can count 1, 2, 3, 4, 5, but you cannot fix. Here fix, here fixed, here unfixed, unfixed. That is infinite, that is finite. Clear? Now here you cannot put all elements within braces. These are the braces, and you cannot put all elements within braces, but you can put all element within braces here to define finite set, and you cannot represent all, you cannot put all elements within braces, that will be infinite set. So this is the whole understanding about finite and infinite sets. Now come at the next point, which is equal sets. What do you understand about equal sets? Can you say both the two sets will be equal? How can you say? Then you suppose that, let's assume a set A and set B. Set A is the consist of 1, 2, 3. Is the consist of A, B, C. Can you say both sets are equal? Can you say? No. If you want to say, yes, these are the collection, there are 3 numbers, there are 3 numbers as well. So number of, if you want to represent a number of A is 3. Here number of B is 3. Can you say these are the equal? No, because for equalness, not only numbers should be equal, but as well as every element should be equal. Here A is the collection of natural numbers up to 3. Here B is the collection of alphabet up to C. But B has no element such that 1, 2, 3, and the same way A has no element such that A, B, C. So we can say that elements are not same. Then this is not equal set. Thus both sets are not equal sets. Clear? This is the whole understanding about the. That means if you want to define equal sets, then what will be understanding? The sets A and B are said to be equal if every element of B is also an element of A. If every element of A is also, if every element of A is also an element of B, then we can say that given sets are equal sets. Here we have defined more point, but we summarized the concept in 2 lines. How? That means it doesn't matter what have you in numbers. If you take less than number, this is not equalness. Less than number, here 1 or 2 is available only, and here A, B, C, but 3 is not the element, 1 and 2 is not the element, then you cannot define this is the equal set. But if you take a number A is 1, 2 and B is number 1, 2, 3, you cannot say this is the equal. You cannot say this is the equal, because 3 is not element of, because 3 is not element of A. 3 is not element of A, so A and B, A not equal to B. So these are not the equal sets. But in the same way, if you take A equal to AE and B equal to AE, that means A is the element of A as well as B, E is the element of A as well as B, then you can say that these are the equal sets. That means you can represent in this way. X is the element of, such that X is element of A and X is the element of B. Clear? This is the whole understanding about equal sets. Now, come up next point. What do you understand about subsets? This is the whole understanding. What is the, now look at these figures. This, suppose this is the rectangular diagram and you have created a circular path and you have written these words subsets. Now guys, rectangular is a whole things and this is element is the subsets of this. That means subsets is existing in circular path, in circular shape, and as well as in rectangular. So subsets is the subset of this circular set. Then we can say that subset is also the subset of this rectangular. The same things we are emphasizing. Now, if you want to define in another way, we need some sets. We can say that a set is said to be subset of B. This is the symbol. A set is said to be subset of B if every element of A, if every element of A, if every element of A is also an element of B, is also element of B, then we can say that this is the subsets, A is the subset of B. Here we are using some example, some notations. This is the condition of one-way implication. So implies that there are two methods to implication. One is one-way implication, one is two-way implication. Implication such that other the symbol is two-way implication. This is also known as if. Here I if that means if and only if. Now but we need only this is used to define this if and if only is defined is used to define equal sets. If there are two equal sets, we can say that each property both have the same property, and if A is not subset of B, then we can represent in this way. So there are two things available here. Whenever we define the subsets, then we come across with equal sets, we come across with not equal sets. Then there are two types as well as to define subsets. Clear? Can you take any element which is empty? If you do not take any element, that means phi, that means empty set. So empty set is the subset of every set, is the subset of every set, because here you do not take any numbers. If you do not take any numbers, then you cannot count, and if you do not put any number, then you can say it is also the subset of. Here we have written. That is the most important point. Here we have in previous point the element of phi is the element of B, but we want to represent phi is the subset of B. That means if you take any number such that natural number, here we have written 1, 2, 3 and so on, then 1 is element of natural numbers, 2 is element of natural number, but phi is also the element of natural numbers. That means phi is the, here phi is the subset of natural number. Sometimes there are mistaken. Phi is the subset of natural number. Because it doesn't have any numbers. Now come at the most important point. Can you define natural numbers is the subset of whole numbers, integers? And here if you put any number which has single element, this is a singleton set. Now here we are getting a two most important point. One is a proper, other is improper. One is proper, one is superset as well, improper as well. But here, what is a proper? If A is subset of B, but A is not equal to B, is defined as proper subset, and A is subset, A is subset, and B is superset. B is superset. That means if A is subset of B and A is not equal to B, then we can say that the given set is a proper subsets, and which is A. If A is equal to B and A is subset of B, then we can say that is an improper subset. Clear? This is the whole understanding about the concept, the subsets, proper subset, superset. That is the point. Now, Q is the subset of real numbers, but Q not equal to R. Now, come at the next point, subset of set of real numbers. Set of real numbers. Now, here we know natural number is the subset of integer, and integer is the subset of a rational number. Now, we can say that rational number is the subset of real numbers, and if T is not a rational number, that means T is irrational number. Irrational number is also the subset of real numbers. Clear? But we cannot say that N is equal to Z. No, N is not equal to Z, T, or anything, any sets. Do you know Q is the rational number, and you can represent Q as a X such that X equal to P by Q form, where Q not equal to 0. So these are the basis of set of real numbers. We can represent the same things. Now, I think this is the clear. We should come on next point, intervals as a subset of R. What do you understand? Interval subset of R. In representation of real line, if you here, this is a real line, and if you take 2 points which is A and B, B is greater than, suppose this is a 0 and this is a left hand side and this is a right hand side, then A is less than B. A is less than B. Here A is less than B. Now, that means there are more numbers availability here. There are more numbers which will be a real number, because this is the real line, but it has a rational number and irrational number. Because we are representing T as an irrational number, then we can say that there are infinite elements and infinite numbers which will be rational number, which will be irrational number, such that if you put any number such that here 0, here 1, then 1 by 2 is the 1 by 2 is the also the part of real lines, because this is a rational number and this is also rational number. Then you cannot limitize this concept. You will get again and again rational numbers, and if you calculate the value of root 2, root 3, which is also the part of real numbers, because you cannot, if you want to write 0.9997777, this number is also the part of real numbers and belongs from 0 to 1. You cannot say this is the 0, you cannot say this is the 1, so you can represent on the line, real number line. Clear? Now, so you can represent these things, these numbers in on the basis of subsets. On the basis of subsets, then there will be the notations which will be very useful, such that this notation is very helpful. Notation are such that A and B. What do you understand about this? This is the closed interval. This is the closed interval. On both sides, this is the closed. That means closed means you can take A, you can take B, and you can take all elements, all numbers from A to B. This is the point. You can take A, you can take B, and as well as you can take all elements between A and B. This is the closed interval. Now, if you represent the same things in this way, that means you are not taking the element A and B, but you are taking all elements between A and B. So this is the representation of open interval, and this is the representation of closed interval, and there are only one difference. In closed interval, you include the elements, ending elements, and in open interval, you do not include any ending elements. So this is a closed, this is an open interval. Now you can represent the same things in another way. Here you can represent closed interval such that you want to write a number x, such that x is the element of greater than x is greater than a, but you include, so you will use equal as well, and less than equal to b. So this is the representation of closed interval. Now come at the representation of open interval. That means you can x such that x greater than a and less than b, but you cannot include a and b. So we will not use equal symbol, because we are not taking a and b, but on the mixed property, that is the point which is semi-closed, semi-open, and semi-closed, semi-open interval, such that if you put a, b, here you want to include, here you want to exclude, then you can represent x such that x is the element which is greater than a, but less than equal to b. Here b is included and a is excluded. So this is the symbol of semi-closed and open, semi-open interval. Now, which is most important point, but one is minus infinity to infinity. This is the symbol of real numbers, but here you cannot take infinitive is the you cannot say that infinitive is the element of real numbers. You cannot say infinitive is not the element of real numbers, but infinity is the elements of extended real number system. You will learn in PG, in Master of Science. You can learn. You will be able to explain what is the extended real number system, what is the complex number system, and you will know complex in intermediate. Now, can you represent the same things on the basis of line as well? Here, this is the line such that, and if you want to include the A, that means you are uh, you are bolding this point, and if you want to exclude, that means open, you are digging. So this is the symbol of this line is the symbol of here you want to include, so you, and B is excluded, so this type semi-closed interval. This is the whole concept of interval as subset of R. Now come at the next point. What is universal set? That is the most important point to understand. Look at these figures. What do you understand? These four students, these four members is the element of this rectangular row. This rectangular white background is also the member of this circular row. Clear? So we can say that this rectangular is a whole world. So you can define it as a universal set, and this circular is a subset. This circular is a local subset, local set, local area in the world. India is the subset and world is universe, is the whole big. So if you take any sets, and the all sets is the sets of real numbers. If you take any numbers, then all numbers can you consider on the basis of class 11th and subsets of real numbers. If you extend your concept, then it will, every number comes under complex number. So complex number is a universal set, and remaining number comes under local sets. Clear? So this is the universal set, concept of universal, and you can define. Usually in a particular context, we have to deal with elements and subsets of basic set which is relevant to the particular context. For example, while studying the system of numbers, we are interested in set of natural numbers and its subset. So we can say that A is subset of B. We can say that. Then A is subset of B. So we can take X as a universal, and A is a subset of X, B is a subset of X as well. Then these comes under universal set. You can say R is universal set. R is universal set because N is subset of R. N is a subset of R. Z is subset of R. Q is subset of R. T is subset of R. So you can say that R is a universal set. R means real number. Now come at the next point. Union of sets and properties. That is the most important point. Here. Next point is Venn diagrams. Next point is Venn diagrams. Can you represent universal set as a rectangular diagram? Can you represent? Now, look at these diagrams. Here, rectangular. And if you put any number such that 1, 2, here 0, 4, 6, 7, 8, 9, 5 as well. What do you think? That means this rectangular is the element of where 1, 2, 3, 4, 5, 6 all natural numbers and so on. But this set is the collection of 1 and 2 only. This set is collection of 6, 7, 8 only. Here, this is the collection of two elements 0 and 4 only. And this is the collection of 0, 6, 7, 8 only. But every set, if this is a universal set, this rectangular is taken as a universal set, then A is subset of X, B is subset of X, C is subset of X. Then X, this type of representation, which is very pictorial view to understand the concept of universal and subsets and differences and intersection, we can represent and we can use Venn diagrams, which is very helpful to understand. So usually the universal set is represent, we can represent it in a rectangular form, and subsets is represented by circle. Clear? This is the whole understanding about Venn diagrams. Now come at the point union of sets and their properties. So what do you understand about union? I have already explained about, I have discussed union of sets, sense of to understand. So union, that means we are strengthening each other, we are meeting with each other. Then what do you understand? If A and B are any two sets, the union of A and B is the set which consists of all the elements of A and all the elements of B. So if there are two elements A and B, and if you include, you can make element C, then C is the element of A union B, where C has all elements of A and all elements of B. You can say that A is subset of C and B is subset of C, while A is equal to B and A is not equal to B as well. But we can say that if you want to define a union, then you can, A is subset of C, B is subset of, so A union B. This is the whole things to understand. We denote union as the symbol of U, as the symbol of cup, and read as A union B. If you take A is a collection of 1 and 2 and B is the collection of 1, 2, 3, then C, if you include A union B, then it is the collection of 1, 2, 3. And for your kind information, you should not write overlapping. You should not overlap any number. That means here 1 and 2, here 1 and 2, but you should write only one at a time. 1, 2, 3. That is the basic understanding. Now, this is the, that means C is the C has a element A union B. That means A union B 1, 2 and 3. If you want, 1 is the element of A union B, 1 is the element of C, 1 is also the element of A. But here A and B is not equal to. But A is subset of C, B is subset of C. This is the whole understanding. And if you want to represent in Venn diagrams, then can you represent the same things in Venn diagrams? Here, which is common? 1 and 2. Which is not common? Which is not common? Here B has 3 and A has a common element. So this is the symbol of, this is the notation of A, this is the notation of B. Now this is the whole notation of C as well. Then you can represent A union B for union where union, this is the universal set. So we can say that A union B as a 1, 2, 3. Clear? Now this is the common point, and these common point also taken as a intersection, and we will define later on here. That means A intersection B. Here is the set A, here is the set B. Now for your kind information, we should understand about the clear concept here. When we are taking A, that means we are taking common element as well. If we are taking B, that means we are taking common element as well. So if you talk about B set of B, that means both elements are available, which is not common and which will be common. If we want to say that only element of B, only element, if you are using only term, then you can say that 3 is the only element of B. 3 is the only, then you will not include 1 and 2. Then these diagrams will help you difference of set, and we will discuss later on. Clear? Now the whole things here represent as a union. Now come at the next point, which is a intersection of sets and properties. First we should define properties of union of sets. Now if you take two sets A union B, then you can say that B union A as well, which is a commutative law. Now this is the first point. Now second point, if you use associative law, A union B union C equal to A union of B union C. This is associative law. Now, third point, which is A union phi. Phi has no element. Then this will be identity element. Here, phi is the identity of union. This is the identity. If you use any element as a identity, and if you take any other element and if you apply operation, then with the help of identity you will get the same numbers. That is the motto for identity. That is the motto. That here you are taking phi as an identity element, A as another element, another set, phi is a identity set. Then if you apply these apply operation, then you will get the same sets, same element. That is the motto of identity. Clear? Now, if you take any other way, such that fourth property, which is fourth property, A union A union A, what you will get? Then you should not write again and again, because union, and if A has the same element, A has against the same element, and you are talking about the same sets, then this will be union as A. That means idempotent element, idempotent law. Idempotent law means if you are if you take any sets and again you are applying for the same set operation, you are applying operation for the same set and you will get the same set, then it's come, this definition it's come under idempotent law, such that A square in the matrix A square is A. If you A, then this will be comes under idempotent law. Now, fifth property, union of any sets. Union of any set, and you apply union of A, then you will get again union, again union. This is the properties of union of sets. Now come at the next point, which is intersection of sets. What do you understand? We have defining, this is the common point, this is the common of any sets. Common, this is the common. Now look at the figure. Look at the figure. What do you understand? We have cleared in union of sets. Now this is the common of all sets. This is the common of all sets. If this is a set A, this is a set B, this is a set C, the circular, then you intersecting each other. There, this is the common point for every set. This is the common point for only B, A and B. This is the common point B and C. This is the common point C and A. But this is the common point for A, B and C. That means A intersection B, A intersection is the inverse of union, such that reverse law, that means A intersection B. In union we use generally the cup symbol, and in intersection we use generally cap symbol. Clear? So A intersection B such that X is the element, X such that X is the element of A and X is the element of B as well. But A union B where X is the element such that X is the element of A or X is the element of B. That means it is not in union, it is not essential, it is not mandatory to include all element, but it is essential, it is mandatory in intersection. If you want to define intersection, then you should take both common element from the both sets. Clear? This is the whole understanding about. Now, then there are more points available here. First, we should define the properties. Now, first property is what will be. We should use property for commutative log. That means A intersection B. If there are common point A between A and B, then it is also common point which is equal to B intersection A. Now, second point, A intersection B intersection C. Now, here we have written most important point. Here this is the associative law. Yes, by default, if there is common A between A and B, then again we take common from C, then it will be because we are the common element for A, B and C as well. This is identity. Clear? Now, we should represent the figure such that here, if we want to represent such that A intersection B, then if whole diagram as a such that this way, here we write this is a B, this is a, and this is a common point which is a representation of A intersection B. Clear? Now this is the representation of A intersection B. Now, in the same manner we can write, if we take this. Clear? Suppose this circle, if you want to overlap, that means you are making the intersection. These leaves representation of common point. That means this intersection 2 points of circle make a chord each other, then we can say that this is the common point where chord is equal chord. This is the symbol of. Now, in the same way, if we are getting union, we are getting strongest sets A and B, and if you want to make in these sets intersection between these three sets, then there is the leaves like a triangular shape which will be common for all sets, Now, here this is the common for A and B. If this is A and this is B, this is C, then this is the common for A and B, A intersection B. Now, These triangular shape A intersection B intersection C, but these it comes under A intersection B, and these things comes under B intersection C. Clear? Now come at the next point, which is difference of sets. What do you understand about difference? Can you balance anything? Here is the grams measurement, here is the articles. If you put, then this decides which is greater, which is lower, which is big, which is small. This decides, this measurement tools decides which is big, then how much this is big, this is, there is a difference. If this is a big and this is a less, then if you subtract it, then you will get the difference of the articles. Clear? In the same way, if this is the set A, this is the set B, and there is the common point, there is the common point, that means the difference of B and A is this difference of B and A, this. That means if you take A as a set such that 1 and 2, and B is the element of 1, 2 and 3, then B minus A, B is greater than A, so B minus A is subtract all elements which has A. That means exclude all element A from B, then you will get only 3. So this is the difference. That means B minus A, here the single point A, only A, that means only A, here only B. In the same way, this is only B. That means in only B this is the 3. So only B is the representation of B minus A, and only A is the representation of A minus B only. Clear? Now this is the representation of A intersection B. Clear? This is the whole understanding about this. If anybody say please represent only A, then you can represent A minus B. If anybody say please represent only B, then you can represent B minus A. Then we can define difference of sets. The difference of sets A and B is in this order is the set of elements which belongs to A but not to B. That means which belong to A. If A minus B, we can here in B minus A, we can say that the difference of the set A and B is the set of elements which belong to B but not belong to A. 3 is not element of A, but 3 is the element of B. Clear? I think this will be very helpful to understand. Now come at the new point, which is complement of sets. This is the very helpful point. Now what do you understand complement of each other? Complement of colors. If there are two colors, black and white, that means in the whole world, if you take a contradictory count like a dark and light, so dark is the complement of light, light is the complement of dark. This is the whole understanding about this. That means you cannot define light if you do not have information about dark. You cannot define light if you have information about dark. Then there is dark and there is a light. Both are connected each other. If this is the symbol of A, so this will be symbol of A dash as well. So complement offset is the whole understanding about. If you take U as a universal set, U as a universal set, which consists of all prime numbers, such that here this is the set of all prime numbers x, such that x is a prime numbers. Clear? Now then what do you understand? If A is subset of U, and can you all prime numbers that are not divisors of 42? If A is the all prime number, set of all prime that are not divisors of 42, that means we can represent the things x such that x is element of union and x is not a divisor of 42. X is not divisor of 42. Then we can say the here if you take 2 as a prime number, 2 is the element of U, but 2 does not divide. 2 does not divide. 2 divides 42. In the same way, 3 and 3 divides 42. 4 to 6, so 3 divides 42. Now 7 divides 42. 7 divides 42. That means 2, 3, 7 are the only elements of U which do not belong to A, because we should write only those number which is not divisor of 42, but 2, 3, 7 is a prime number which divides 42. So we cannot include 2, 3, 7 in A, but we can include 2, 3, 7 in U as well. That means 2, 3, 7 is the element of universal, but 2, 3, 6 is not the element of A, but A is the subset of U. That means U is the superset, A is the subset. Clear? Now we can say that A is the complement of U. We can say that A is the complement of U, like dark and light. Clear? Like dark and light. That means how can I represent this point such that A dash here x is the element of x, such that x is the element of universal U, and x is not element of A. X is not element of A. Clear? Then we can represent in this way U minus A. That means when we represent A dash, then we exclude A from union, from universal. Clear? Then now come at the next point, some properties of complement offset. Now complement law, such that if first point, this is the, if A union A dash, that means we include A and we do not include A, and if you take union of both sets, then you get union, then you get universal, because if you include dark and light, then the whole universe will be the set. Now second point, if you take A dark and there is a difference, there is a common point, dark and light, can you define any common point? No, there is no common point between dark and light. If you look at dark, then it will be whole dark. If you look at light, this will be whole light. So there is no commonship between dark and light. So this will be 5. Third point, De Morgan's law, which is very important. This is a complement law. Now, De Morgan, which will be very helpful. A and B, there are two sets. If you take union of these two sets, and after union, if you take complement, then that means you are excluding A union B from union. Clear? That means I will represent the same things in the Venn diagram, but here A dash intersection B dash. That means here if A union B dash, then if you want to open this, then it comes, this complement comes under comes from for A and B, then you will change their sign. That means union comes under intersection. Now fourth point, A intersection, this is the same things, A intersection B dash equal to A dash union B dash. And if you, this is a light, and if you put again complement, this will be dark. So A is the dark. Now sixth point, empty set. That means empty set, complement of empty set is universal set, and complement of universal set is the 5. There is no. Clear? Now we should take help for the same things in Venn representation. Okay, now take this. Now look at this, the pen here. This is the universal set, rectangular representation for universal set, and if you represent this set, there is A such that this is the A. That means if you fill this color, that means this is the A, this is the A. This is the A, and here white, this white is a representation. Suppose if you fill this another way to color, this yellow color, yellow of color is the you can say this is A dash. Clear? And if you mix, that means if you take union, what you will get? You will get universal, which will be rectangular element. That means it is the representation of That means you can say that U equal to A and A dash, A union A dash. Clear? Now come at new point. If you draw a diagram such that here there is any common shift between A and A dash, there is no common, so we can say that A and A dash is phi, a empty set. Now here we are defining De Morgan's law, which is A union B dash. First we should make the 2 point. Here this is a shape, circular shape, and this is a clear. Now this is the shape such that here we are filling this color and we are filling this color in this way. Now what do you understand about this point? That means A union B. If you want to represent A union B, then 3 colors. There are 3 colors: red, blue, and white. White is taken as a common. A intersection B. If you write this is A and this is B and this is A intersection B. Clear? Now the whole diagram this will be A union B, and whole diagram is A union. Clear? So what do you understand? The white background such that this pink background we will make pink background. This pink background is the complement of A union B. Is the complement of A union B. How can you say the same things? That means A union B, A union B dash equal to, that means you are excluding A union B in union. The same meaning of this, that means this pink background, this pink color. Now the same things we will say on the basis of A dash intersection B dash. This will be equal to A dash intersection B dash. How can you say that? If you say A and A dash will be the whole except of red color, except of red color, that means blue, white, and pink. Blue, A dash means blue, white, and pink, and B dash means red, white, and pink, and the common A dash B dash, the common is white and pink, white and pink, white and pink. Now A union B, if you talking about A dash, that means you are not including this white as well, so we should exclude this. Then you will get pink only. Here this is the pink only, so this will be equal, because if you talking about A dash means the whole A dash except of whole A dash. That means A dash means blue and pink, and B is the common of. B will be common for, because B comes under, B is the subset of P. B is the subset of P, and R is the subset of pink. Red is the subset of pink, blue is the subset of pink. So pink will be higher. Pink will be the same things. That means here this is the most important because it gives the whole information to understand. If you imagine the concept, then you will get the understanding. Clear? This is the whole things which will be useful. Complement of A dash, again you will get red here. So this is the whole understanding on the basis of Venn diagram. Now guys, we have covered all things related to sets, representation, types of sets, Venn diagrams, universe, union, intersection and differences, complements. We have covered all topics on the basis of class 11th mathematics chapter 1 on the basis of NCERT. This theory will be very helpful to solve related problems on the basis of, there are many exercises and we will solve separately each and every exercises of given chapters. So guys, thank you for your dedication, for your patience. This was the first class of class 11th mathematics. Thank you guys.